Hi, my name is Miranda McIntyre, and I'm a sophomore in the International Business and Logistics program at Maine Maritime Academy. Today, I'm going to discuss the topic of Ekman transport and the incredible journey that Fridtjof Nansen went on in order to discover it. But first, we will meet a few marine science students to see what they know about the topic.
Hi, I'm Susanna DeFrank. I study marine biology and SVO at Maine Maritime Academy.
Hi, Susanna. I was wondering if you could tell us if you're familiar with the topic of Ekman transport.
Yes!
Now, can you tell us anything about Fridtjof Nansen, who first discovered it?
No.
That's okay. Thank you, Susanna.
Hi, my name is Lauren McKenna. I'm a senior in the Marine Bio and Small Vessel Operations program here at Maine Maritime.
Hi, Lauren. I was wondering if you could tell us what you know about Ekman transport.
Okay, so I don't know too much, so I feel like that's more on the science side than the bio side, but I know it has something to do with the wind coming across the surface of the water and the Coriolis effect maybe, and basically if the wind is going this way, then the movement of the water underneath is going like at a 90-degree angle that way.
Thanks for your help, Lauren. We're going to get more into it as the presentation goes on.
You're welcome.
Fridtjof Nansen was a Norwegian explorer known for his adventurous life. In 1893, he and a team went on an incredible journey to the Arctic. The goal of this journey was to cross the North Pole and to observe the influence that currents have on pack ice. In preparation for their journey, Nansen and his team had a special vessel built. Their vessel was 128 feet long, made of wood, and very unique. Their vessel, named the Fram, was unique because it was built specifically to be frozen into the pack ice. Once Nansen and his team reached the Arctic, they allowed the Fram to freeze into the pack ice. They were about 680 miles from the North Pole when they started. Nansen hoped that the drifting of the pack ice would carry the Fram to the North Pole. Nansen and his ship stayed locked into the ice for almost 3 years. However, they never reached the pole. At one point, Nansen and one of his crew members made a run on foot for the North Pole, but they were unsuccessful. Despite Nansen and his team never reaching the North Pole, the trip was not completely unsuccessful. Nansen and his team made an important observation. They noticed that the direction that the ship was moving was consistently 20 to 40 degrees to the right of the wind direction. Later, in 1905, a man named Wilfred Ekman would mathematically describe this and formally name it Ekman transport. Ekman showed that, in fact, the wind and the water would move at 90-degree angles to each other. Ekman transport occurs when there is friction on the water's surface due to wind. This, combined with the rotation of the Earth, causes the surface currents to move at an angle to the wind. The movement of Ekman transport causes objects to move 90 degrees to the right of the wind in the northern hemisphere and 90 degrees to the left of the wind in the southern hemisphere. An example of Ekman transport is when the wind blows in one direction, but an iceberg, which is very large and has a lot of mass underneath the surface of the water, moves in a different direction to the wind. This concludes my presentation on Ekman transport. I'd like to thank Lauren McKenna and Susanna DeFrank for helping me with this presentation, and I hope you all enjoyed it. I'd also like to give credit to Ocean Motion and Surface Currents, a website by NASA, and Flickr Images with the following photographers.